Hello everyone, welcome to Study EETech. In this video, we are going to learn half wave rectifiers. As we know that the rectifiers are AC to DC converter and half wave rectifier is the simplest circuit in this category. You can expect questions from here in the GATE exam. Based on its waveforms, the conceptual questions are set, and based on its mathematical formulas, the numerical questions are set. First, we will see what is the circuit diagram of half wave rectifier. We see that the input voltage is connected to the primary side of the transformer and the load is connected to the secondary side of the transformer through this diode. That makes the circuit diagram of half wave rectifier. Few things are to be noted here, like the input voltage is 50 Hz AC supply, that means 20 millisecond is the time period. The diode acts as a switch. As we know that the IV characteristics of the diode is this one. In the forward biased mode, the diode allows the current to flow through it, and in the reverse biased mode, it blocks the voltage. That means the diode acts as a switch. The forward biased mode can be represented by this on switch, and the reverse biased mode can be represented by this off switch. Now we will learn the operation of the circuit. The input is a sinusoidal voltage, that means its polarity keeps changing. In the positive half cycle, we can say this terminal voltage is positive and this terminal voltage is negative. Assuming the dotted terminal of the transformer are here, this voltage will be positive and this voltage will be negative. Now looking at this circuit, we can see that the anode terminal of the diode is facing the positive voltage and the cathode terminal of the diode is facing the negative voltage through this path. That means the diode is in forward biased mode, and we have already seen that in forward biased mode the diode is a short circuit. So the equivalent circuit will be this one. Where we have replaced the diode by a short circuit, we are assuming there is no voltage drop at the diode during its on state. So this positive voltage will directly appear here and this negative voltage will appear here, and we will get the output voltage. Now what will be the waveform? This is our input voltage, which is sinusoidally changing from 0 to pi positive half cycle, and in the positive half cycle this is the equivalent circuit, and as the output voltage is equal to the input voltage, we are assuming here 1:1 transformer and we are considering this to be input voltage. So from 0 to pi is the positive voltage. So if the output voltage is equal to the input voltage, then this voltage will be copied and pasted over here. So we will get the output voltage to be this one from 0 to pi. Now from pi to 2 pi, the negative half cycle is there. That means the input polarity will change. So this negative is going here and the positive is coming here. Subsequently, these two voltages will also alternate. That means now the anode of the diode is facing the negative voltage and cathode of the diode is facing the positive voltage. That means the diode is in reverse biased mode, and in reverse biased mode the diode is a off switch, meaning the equivalent circuit will be this one. By looking at this circuit, we can directly conclude that the output voltage is equal to 0 because there is no path for the current to flow. So I equal to 0, I into R equal to 0. So we will get the 0 voltage here. From pi to 2 pi, that's why we see there is no voltage is appearing. That means 0 voltage we will get at the output. And from 2 pi to 3 pi, 3 pi to 4 pi and so on, the same process will repeat. That means we will get this sort of voltage at the output. Now we see here, out of this whole voltage, we get the output only in the positive half cycle. In the negative half cycle, we do not get any voltage. That means in the output we get half of the input voltage, and that's why it is called half wave rectifier. In the next video, we will calculate the average voltage and RMS voltage. But before watching the next video, try to answer these questions. What will be the waveform of the voltage across the diode? I have not drawn what will be the voltage across the diode here. You try to answer that. Next question is, what will happen if the diode is reversed? Meaning the anode will be here and the cathode will be here. In that case, what will be the output voltage waveform? And what will happen if the single diode is replaced by two anti-parallelly connected diodes? This question may be a little bit tricky, but try to understand that because your concepts will be better and that will ultimately help you to score well in the GATE exam? You try to answer these questions and let us know in the comment box. In the meantime, if you are new to this video, Study ETech is dedicated to all the electrical engineering students. We promise to offer you the best quality video lectures, study materials, and the career guidance. Our motto is to make Study ETech a complete platform for all the electrical engineering students. So a little bit support from your side is required. Subscribe to our YouTube channel, follow our Facebook page, and visit our website. Thank you.